All right, kids. This is going to be thermochem homework number 1. We are going to see if we can make sure I can read this. Thermochem homework number 1. I'm starting out with the Fruit Loop question. Fruit Loops are good to eat when you're a kid, but they're not healthy to eat when you're an adult. And it says that 38 grams is going to equal 125 food calories. That's a capital C. Those are actually kilocals as opposed to just calories with the little c. Those are the food calories, the big ones. And we have to convert that many calories first into cals, and then we also have to convert it into joules, and we also have to convert it into kilojoules. So we're going to start out with 125 food calories over 1. And we know a few things. We know that 1 food calorie is equal to 1,000 cals. So we could say 1 big C is equal to 1,000 cals. The C's cancel, and 125 food calories equals 125,000 cals. Now, it's the same exact amount of energy, but if you were going to eat it, 125,000 sounds too big, so we use 125. It sounds a little more palatable. The next problem, we're going to take the same starting point, 125 food calories, and we're going to have to convert that into joules. Now, we just figured this out. So we're going to actually use this number instead. We're going to say 125,000 cals. And we remember that each cal is 4.18 joules. The cals will cancel, and now we have to use our calculator. 125,000 times 4.18, and that equals 522,500 joules. And then we have to round it to 3 significant figures, 523,000 joules. In our third step, we're going to take those joules. Let me show you with the arrow. We're going to move this over here. 523,000 joules over 1, and there are 1,000 joules in 1 kilojoule. Kilo is 1,000. 1 meter is small, a kilometer is big. In 1 kilometer, there's 1,000 meters. In a kilogram, there's 1,000 grams. And a kilojoule, there's 1,000 joules. The joules in the numerator and the denominator cancel, and this is a mathematical division, so the answer is going to be 523 kilojoules. That's question number 1. Now, question number 2, we're talking about cashews. Cashews are nuts. And the question provides us with this: 28 grams equals 165 calories. And the question says, how many calories, joules, and kilojoules are in 64 grams? 64 grams. And it also gives you a reminder, this question is not about 165 calories. 28 grams gives you 165 calories. That's going to be in proportion to 64.0 grams to X calories. If we only ate 28 grams, we'd only get that many calories of energy. But nobody eats 1 serving usually. You just grab a handful of them. If you weigh them and you eat 64 grams, you'd end up with a lot more calories. So when we cross multiply, we're going to get 28x, and that's going to be equal to 10,560. We're going to divide both sides by 28. X is going to equal 377 calories. Now, that's the number that we have to convert into cals, joules, in kilojoules. So the question's not about this, the question is about this. So let's do this work. 377, oops, let's write it correctly. 377 calories. One food calorie is equal to 1,000 cals. 377,000 cals. That's our first answer. We'll move this so you can see it better. Oops. I don't know my left from my right with this camera. Then we're going to take 377,000 cals over 1. And remember that 1 cal is 4.18 joules. This I can't do in my head. 370,000, can you see that? Times 4.18. And that equals a lot. 1546600. And we're going to round this to 3 significant figures, so it's going to be 1550000 joules. Now we're going to take that number, 1,550,000 joules, and it's still 1,000 joules in 1 kilojoule. The joules in the numerator and the denominator cancel, and this becomes 1550 kilojoules. How's that looking, kids? You getting that? I'm going to check my math again. 377,000 times 4.18. 1. Oh, you know what? Nobody said anything to me. I made a little boo-boo. Let's do this question 2 and question 3 again because I made a little boo-boo. 377,000 cal over 1 times 4.18 joules over 1 cal. Let's show you what I'm doing. I actually made a little math boo-boo, and this is equal to 1575860 joules. Oops! And with 3 significant figures, it's going to be 1580000 joules. And then when we convert that number, 1580000 joules over 1. Let's get this in the picture. And 1,000 joules is 1 kilojoule. It's going to be 1580 kilojoules. I'm sorry about that. When you make one dopey mistake, it's going to just keep pushing through, and that is a problem. You don't want to do that. You want to be careful. I was not careful enough. Question 3 is about 346.0 grams of water. Actually, it's the ice phase, and how much to melt it at 273 Kelvin. So we're starting right at the melting point. So the formula that we're going to use for this is going to be Q equals mH of F. This is the heat is going to equal the mass times a constant called the heat of fusion. Now, the heat of fusion constant is the amount of energy it takes to melt 1 gram of a substance. And for water, that number happens to be 334 joules per gram. So the question here is, how many joules of energy will it take to melt that many grams of ice without changing its temperature? The question is going to be written this way. Q equals 346.0 grams times 334 joules per gram. Now, this heat of fusion constant, that means if you have 1 gram of ice, it takes 334 joules of energy to melt it. If you'd have 2 grams of ice, you'd have to multiply that constant by 2. If you had 10 grams of ice, you'd multiply it by 10. In this problem, we have 346 grams of ice. We'd have to multiply this constant by that many grams. The grams in the numerator cancel the grams in the denominator, And the Q is going to equal 346.0 times 334, or 115,564 joules. And then we're going to round this. We have to see about significant figures. This has 4 significant figures, and this has unlimited. So we're going to need 4 significant figures. This is going to round to 115,600 joules. That's going to be the answer. The last problem is about steam. And it says, what happens if 2.90 grams of steam condenses on your hand? First of all, it's going to hurt like hell. How much energy in joules is released when this steam turns into gas? Now, this is going to require a slightly different formula. Q equals mHV. Now, HV is called the heat of vaporization. That's another constant. Every substance has one. Now, the heat of vaporization constant is the amount of energy it requires to vaporize 1 gram of a substance into a gas, or how much energy is released when 1 gram of a gas is condensed into a liquid. For water, this is listed on table B, and the heat of vaporization constant is 2260 joules per gram. This is a constant that's written down for you on the reference table. That means that if 1 gram of water, 1 gram of steam condenses into water on your finger, you would have this much energy released. Well, we don't have 1 gram, we have this many grams. So to do this, we write the formula, Q equals mH of V, and the amount of energy Q is going to equal 2.90 grams, and each gram is going to provide 2260 joules per gram. The grams in the numerator and the denominator cancel, and we're going to do 2.90, let's put this where you can see it, 2.90 times 2260, and the Q is going to equal 6554 joules. But we have to round this to 3 significant figures. There's only 3 significant figures here, so the answer is going to really be 6550 joules. This is the end of homework 1. The end of homework 1. Let's put a smiley face here. Thank you so much for coming and playing. Bye-bye.